Now let us continue this abnormal molar mass. Yesterday we discussed about the calculation of molar mass, that is the determination of molar mass from the colligative properties. So these are all theoretical, that is the molecular mass only. But when we examine practically with other experiments, there are some deviations. So such type of phenomenon is known as abnormal colligative property, and because of that, abnormal molar mass is obtained. Let us discuss one by one. Colligative properties generally it is determined by dilute solutions, as we already discussed. Dilute solutions, okay, and these solutions they obey Rolle's law and they are called ideal solutions. So the solutions which obey Rolle's law are called ideal solutions. But there are some deviations noticed in Rolle's law. Okay, this is because of increase in concentration of solutions. Okay, now when we consider some solution, they deviate from Raoult's law, and such type of solutions are called that is non-ideal solutions. So in the case of ideal solution, there is intermolecular force, but in spite of that, these are negligible. So in case of ideal solutions, intermolecular forces in the solvent are negligible, like in the case of ideal gas and real gas. Then, in non-ideal solution, this intermolecular forces are considerable. So there is some intermolecular force of attraction, and that is responsible for the dimerization. Now let me discuss. You know the formula of acetic acid. You think that this acetic acid formula is CH3COOH, acetic acid. And what is the molar mass of acetic acid? So let us work out CH3. There are two carbons, so 24, hydrogen 3 plus 1, 4, and there are two oxygen, is it not? So 32, 2 into 16, 32. So how much? 4 plus 4, 8, 2, 10, balance 1, so 6. So we think that that is definitely we will get 60. But when we check the molecular weight obtained from the experiment conducted using this colligative property, it gave 120. Okay, so it means that there is some difference. Okay, so this is because of association of acetic acid. So being a dimer, this colligative property has been mistaken that is this is as a single molecule. So let us consider CH3COOH, CH3 and C double bond O O H, and let us consider another CH3COO. Okay, like this, CH3 C double bond O O H, and this is CH3. So these two molecules, they may join due to association among themselves, okay, because of hydrogen bond, and I have indicated this by yellow line. Okay, so because of this intermolecular hydrogen bonding, there is an association. Such type of liquids are called associated liquids. So this has resulted dimer. Are you able to understand? And that is why there is a difference in molecular weight. I hope now you are able to understand. So when we conduct the experiment, that is a colligative property with such kind of a molecule, we are able to get 120 as a molar mass of acetic acid. Okay, but that is truly speaking, when we work out theoretically, now it gives 60 only. Is it not from the molar, I mean molecular formula? So why there is a difference in the molar mass? And that is called the abnormal molar mass. It is because of the association. I hope now you should be able to understand this. So non-ideal solutions show deviations in colligative properties. Are you able to understand? So from this, acetic acid is a ideal solution. Why? Because there is an intermolecular force of attraction because of intermolecular hydrogen bonding. Okay. Now, Electrolytes undergo ionization in aqueous solutions. As a result, number of particles in the solution increase in magnitude. Okay, and increase in magnitude, other colligative properties increases. And colligative property and molar mass of solute are inversely proportional. Understand this point. Colligative property and molar mass, they are inversely proportional. Okay, so this is a very important point. Okay, so we will explain based on the colligative property. Okay, then molar mass of electrolytic solutes. Okay, what is electrolyte? Electrolyte is an acid. It can be an acid or base or salt which can conduct electricity when in molten form or in solution form. So normally for electrolytes, that is like a sodium chloride solution, hydrochloric acid solution, etc., they are less than the true value. Understand this. So some solutes when dissolved in solvents may undergo association also. Okay. So they form dimers or trimers. So dimers, as in the case of acetic acid, I had explained. Okay. Right. Now, due to the association, okay, in number association number particles, due to the associated number of particles, the solution decreases. Okay, because of this, I mean, association number of particles, they decreases. Is it not? For instance, let me say there are 30 number of molecules in acetic acid. Okay, but apparently it seems to be only 15. Why? Because they dimerize. Are you able to understand? So they'll be having 15, 15 as pairs. So there is a decrease in number of solute particles. I hope now you are able to understand this. Okay. So there is a, in case of associated molecules, the number of particles in the solution decreases. I hope you are able to understand this. Then, as a result, the colligative property decreases because we have already suggested colligative property is proportional to what? The number of moles. In this case, when it decreases naturally, that is, there will be a difference in the property. Okay, right. So, molar mass of such solute will be higher than the true value. Okay, and that is why Van Hoff, he introduced a very important factor that is called I in the equation in order to equalize the experimental value and the calculated value. Pi V is equal to nRT. So this is the osmotic pressure. Is it not? This is the equation for osmotic, increase in osmotic pressure. So pi V is equal to RT. But we have to introduce I factor here. So therefore, what is I? The want of factor, which is nothing but the ratio between experimental colligative property and theoretical colligative property. I mean calculated colligative property. Please note down this. So this is very, very important, and there are so many questions asked based on this abnormal mass and the abnormal colligative property. Okay, so that is why here we have mentioned the experimental value of colligative property divided by calculated value of colligative property. So the ratio between them is called I factor, that is want of factor. Okay, so and when you look at in case of osmotic pressure, there will be an observed. Observed means experimental. Okay, now so that's what we have explained here. The same is repeated here. Okay, right. Now for solutes, listen to me. For solutes, how it is calculated? For solutes that undergo dissociation or ionization. For instance, in case of NaCl, that is, it gets immediately ionized, being a strong electrolyte in presence of water to become Na plus Cl minus. Okay, so that is why there is an ionization or dissociation. Okay, so on solute on such ionization, it gives n number of ions, is it not? So n number of particles. So instead of appearing one, it appears as two, is it not? For example, BaCl2, it appears as three. How? BaCl2. Okay, now when it ionizes in presence of water, what happens? Ba2 plus Cl minus, that is 2Cl minus. So there is only one Ba2 plus and two negative ion. So totally 3 ion. Okay, so instead of appearing as a BaCl2, now it, that is confuses the colligative property with three ions, and that is why we have to compensate this. Okay, so alpha is the degree of ionization because everything is accounted here. So which is responsible for ionization? Alpha is responsible for ionization because alpha is equal to 1 in the case of strong electrolyte, but it is less than 1 in case of weak electrolyte. So degree of dissociation means, or degree of ionization means what? The number of ions are produced divided by total number of ions. Okay, it indicates to what extent the ionization can take place. Are you able to understand? Right. Now, so 1 plus n minus 1 into alpha particle ions. Okay, so that has to be, that is taken into account. So let us consider an number of I mean electrolyte is there, n number of A is obtained. So initially there was one and there was no product, but after certain seconds, what happens? 1 minus alpha. So the remaining is 1 minus alpha. And what about this? This is n number of alpha produced. Okay. So the total number of alpha means, so that is we have to add everything. So 1 minus alpha plus n alpha. So 1 minus alpha plus n alpha. And that is why we get 1 plus n minus 1 into alpha. Are you able to follow? So I is equal to the number of particles of dissociation after dissociation divided by number of particles. So in this case of dissociation, we have to highlight this. That is, what is I? Number of particles after dissociation divided by number of particles before dissociation. Okay. So therefore, number of particles after dissociation means we know already, that is I plus n minus 1 into alpha. This is after dissociation, and previously it was only 1, and that is why we had taken I as what? 1 plus n minus 1 into alpha. This is a very important equation, and where from we can calculate the degree of dissociation also based on the want of factor. So you can rearrange, for instance, that is you have I that is equal to 1 plus n minus 1 into alpha. So you can bring this I this side. So I minus 1 is equal to n minus 1 into alpha. Therefore, alpha is equal to I minus 1 divided by n minus 1, and hence the formula. Are you able to understand? So this is a very important formula, and from this we are able to calculate the degree of dissociation also. Okay, right. Now let us just look at this table. Alpha is the degree of dissociation or ionization. So for sodium chloride, the want of factor for complete ionization dissociation is 2. For sodium potassium chloride 2, magnesium sulfate 2, K2SO4 3. Why? Because sodium chloride, sodium 1 ion, chlorine 1 ion. So 1 plus 1 2. Are you able to understand this? How we get it? Then KCl. Okay. KCl 1 plus 1, and similarly 2, and magnesium sulfate, how it is going to ionize? Mg2 plus plus SO4 2 minus. So each one ion only, is it not? So 1 plus 1 2. And what about K2SO4? K 2K plus plus SO4 2 minus. So it means 2 plus 1, that is 3. So that is where you have got 3. I hope now you should be able to understand this. And for associated liquids, we had to calculate like this. So n number of A, it is going to associate to become AN. So initially it was 1. After certain seconds, there is no, initially it was 1 and there was no product initially. Then after certain time, 1 minus alpha is the remaining number of moles, and here alpha by n. So total particle after dissociation means 1 minus alpha plus alpha by n. Okay. Now we get I is equal to, we have to calculate because before dissociation, after dissociation, we had to divide, is it not? So before dissociation, it was 1. After dissociation, it was the numerator. So when we divide by 1, you get the same numerator. So I is equal to, so you can work out similarly. Okay. So this is for association. So alpha dissociation, alpha association, you should remember. Okay, so in colligative property, we have discussed the variety of colligative properties. What are those colligative properties? Elevation of boiling point, depression of freezing point, increase of osmotic pressure, and relative lowering of vapor pressure. And we started this topic with what? The concentration, expressions of concentrations. Okay, molarity, normality, you should know something about formality also, and that is the percentage concentration, mole fraction, molality, and you should know something about the parts per million also. So these are all the various concentration terms that we discussed in this topic. And in the case of what you call that is colligative property, we started with the derivation of elevation of boiling point, depression of freezing point, everything one by one. And we discussed in detail about osmotic pressure and what is ideal solution, non-ideal solution, and what is a Henry solution, and what are the different types of solutions: solid liquid solution, liquid solution, gas liquid solution, and where the Henry's law is applicable. We are discussed in detail in this topic. Okay, so please go through this topic. Solution is one of the very important topics in chemistry, and you may come across various types of challenging questions here. So there will be a lot of numericals. So you have to practice very well. Okay. Thank you very much for watching this video.